Good evening, viewer. Welcome to our Glory Globe TV. Here's a breaking news. Yes, different types of nanomaterials have been used in neuroscience, including two-dimensional nanomaterials widely known for their unique structures and physicochemical properties. In a recent Journal of Nanobiotechnology review, scientists discuss the application of 2D nanomaterials in neuroscience. The thickness of 2D nanomaterials is typically between one or more atomic layers, wherein electrons move freely in the other two dimensions beyond the nanoscale of less than 100 nanometers. Yes, these materials exhibit superior biological and physiochemical properties and have been applied in regenerative medicine and tissue engineering. Some common types of 2D nanomaterials include graphene, layered double hydroxide, that is called LDHS, black phosphorus, that is called BP, transition metal carbide, that is called TMCs, and transition metal di. Many of these nanomaterials are used in neuroscience, particularly for neuroinflammatory reduction, injured neural cell tissue repairment, synaptic modulation, and stem cell fate regulation. Graphene, the first discovered 2D nanomaterial, comprises carbon atoms covalently bonded in a hexagonal lattice. 7 functionalized forms of graphene-based nanomaterials have been developed, of which include carboxyl graphene, graphene oxide, and reduced GO. Another 2D nanomaterial that has recently gained much attention is TMDC. The generalization formula of TMDCs is MX2, where M is the transition metal atoms sandwiched between two layers of calogen atoms. In 2014, scientists discovered 2D BP, which consists of stable allotropes of phosphorus that were collectively between 1 and 2 nm thick. LDH interact with organic molecules through the anionic exchange, which is characterized by a phenomenon known as intercalation. The nanomaterial is chemically stable with pH dependent biodegradability. Different types of 2D nanomaterials have been applied in various aspects of neuroscience, such as neural repair, synaptic stimulation, neurodegenerative disease, and glioma. The nervous system has a poor ability to regenerate axonal connection after injury or disease. In addition, it is difficult for drugs to reach damaged areas through the blood-brain barrier. Recently, 2D nanomaterials have been extensively explored for their therapeutic potential, particularly in neural repair and regeneration. Since GBNs exhibit significant electrical conductivity and good biocompatibility, they are excellent candidates for neural tissue engineering. Graphene substrate has been used as cell scaffolds with optimal electrical stimulation. Furthermore, graphene substrates have been shown to support cell adhesion and promote cell proliferation policy, that is called lactic coagylic acid PLGA. Nanofiber pads coated with geo and methylene blue, that is called MB, improve the ability of neural progenitor cells is counter disease threshold. Moreover, 2D nanomaterials have been issued in the development of artificial synaptic devices and processes, optoelectronics, electronics, electrochemical and mechanical properties. Graphene, coupled with other materials, forms heterogeneous structures that function as artificial synapses. For example, graphene tantalum pentoxide graphene phototransistor exhibits synapse characteristics visible under electromagnetic radiation. NDs are chronic disease characterized by neural and neuronal degeneration and myelin damage, which cause cognitive impairment and morbidity in older adults. Three major types of NDs include Parkinson's disease, Alzheimer's disease, and Huntington's disease, all of which are associated with protein aggregation or misfolding. Beyond the report, Globe TV, Delhi, India.